So now, in order to calculate a 5-step binomial tree to estimate the value of a call, we first need to calculate these values here in red, which are done using these values up here. So the first row of the asset price is equal to the stock price, as you can see there. We then, to calculate this one, we multiply by the up value and F4 the U and drag it all the way across so that they're the same values. So that's the likelihood that the stock will go up. And then if the stock goes down, we multiply it by D. And again, we F4 that and drag it across. And so on it's the same way for the rest of it. So now we're going to look at the intrinsic values. So this is max, so that the values come out positive, and for the call it is the stock price minus the strike price. So we drag that all the way down here as the strike price is F4'd. So we can drag it all the way down, and then to get the option price to build our tree, we have to let the intrinsic values of this row here equal to this column here equal to this column here, which we have done. So we have to work backwards in order to build our tree. So we'll use this formula here to calculate the final value of our tree. So as you can see here, it is the EXP minus the risk-free rate, and we F4 that, which is multiplied by the time period in question, which is dt, and we also F4 that because it's going to be constant, multiplied by P, the risk neutral probability, and we will F4 that as well. And then we multiply by the previous cell here, the previous value, which is the same as this value here, plus 1 minus P, which is the same as this P here that we calculated, multiplied by the lower value here, the 30.78. And if we do that, we get 43.55, and if we drag it the whole way across, it stays the same, and drag it all the way down, and the value here then will be equal to the Cox-Rox-Rutenstein, which is correct. Here we can see that the call time value is similar to Black-Scholes, but it's not the same. So also, if we use C++ to estimate the value of a call, we can see that it is similar to the Cox-Rox-Rutenstein and the 3 here, but it is different to the Black-Scholes.